Hi everyone, welcome to our 8.2 lesson. We are looking today at modeling linear systems. We're going to start by just modeling a linear equation, and then we're going to take that to the next level where we have two equations, which is a system. Okay, 8.3 I'll cover in another lesson here. So 8.2 is what we're looking at right now. Let's first of all talk about what does this word modeling mean? What does it mean to model? It doesn't mean to walk down the runway, with math equations. Modeling means to take a problem, or two problems, if in our case, that are given in words. So these are word problems, and you change them from a word problem to an equation. So you're writing an equation for a real life situation. That's what modeling means. So let's for ourselves define that. So modeling means to change from words to an equation. And in our case, the type of equation we're going to be using is a linear equation. So y equals some slope x plus the y-intercept b. So we're going to put our equation in slope-intercept form. So how do we do this? We start by, we're given a problem. It's in words. We have to sort of deconstruct the problem, and we have to assign some letters. Variables are letters. We're going to assign some variables. For example, x and y. Okay, but this could be or any letters. Okay, it doesn't have to be x and y. It's just that we're used to working with x and y. To whatever quantities are in the problem. So the things in the problem that are changing, we have to assign a letter to them. The quantities that change at a constant rate are going to be straight lines when we graph them against each other. So remember that rate of change is equal to your slope. The rate of change of something, so the change in one quantity, let's say y, over the change in x, is your slope, m. Okay, so any problem where you have a constant rate of change, this is a linear equation. And we can write a linear equation then for it. So I remember a linear equation is written as y equals mx plus b. Okay, and when we write that out, the slope, let me write it again right here. Okay, the slope m will be your rate of change. Okay, it's a change in y over the change in x, or whatever your variables are. B is your y-intercept. That will be the initial amount or the initial value for y. Okay, or for quantity 1, whatever we call it. So let's do a real example of this. So I have a tank is being filled at a constant rate of 20 liters per minute. Okay, so right away, this is a rate of change. 20 liters per minute is a rate of change. Okay, 20 liters on the top per every 1 minute on the bottom. Okay, and that is going to eventually be my slope. But right away I have a constant rate of change. Okay, the tank contained 40 liters to begin with. So this is the initial volume. 40 liters is what the tank started off having in it. Write an equation for the volume of the tank. So in other words, let's show an equation that at any particular time I could figure out how many liters is in the tank. Okay, so first of all, let's think about it. We have a constant rate of change. So if I started off with my tank, let me draw a tank. If I started off with 40 liters in my tank, there's my initial amount. Okay, every minute, so this is at t is equal to 0, 40 liters. This is my initial amount. Okay, at t equals 1 minute, so after 1 minute, what would be the volume of my tank? Well, I would have had the 40 liters that I started with, plus it would have gone up 20 liters. my rate of change every minute, I'm going up 20 liters. So I would have another 20 liters on top of that 40. In other words, after 1 minute, I would have 60 liters. So even a diagram can just get us thinking about this. What is, what would be the answer? So whatever number I put in for time, however many minutes, I know that I'm going up 20 liters for every single one of those minutes. So the first thing I'm going to do is I'm going to start by assigning some variables. Okay, so we're going to assign 2 letters, 2 variables. So let's let, well, what are the 2 quantities that I have in this problem? The first quantity is volume. So let's let the volume of the tank, okay, which is in liters, let volume be represented by a letter. Now you could use the letter B, which would be really good. We could also have a look at this and think to ourselves, if we want to use X and Y, if you look at your rate of change for a minute, 20 liters per minute, whenever you graph one variable against another, time is always graphed on our x-axis. This is true. So we're going to let time in minutes be our x, and let's let the other variable, which is volume, be our y. Okay, so let's let y represent volume, and let's let time in minutes be represented by the letter x. We can make a little note here to ourselves if we want to. Time is always graphed, almost always graphed on the x-axis. So we would always assign a variable of x if we were choosing x and y to time, and the other variable would be y. Okay, and so we could come up with an equation for this, and it's going to look like this. This is I have a constant rate of change, so I can say y is equal to mx plus b. I can write a linear equation for this problem because I have a constant rate, which is a constant slope, and I have an initial volume. Okay, so here y is going to represent my volume, and x is going to represent my time in minutes, and my volume will be in liters. And if I come back to my original information that I'm given, the rate of change is 20 liters per minute. That is equal to my change in y, my change in volume over my change in time, which is x. Okay, and so therefore this is equal to my slope. So m is equal to 20 over 1. So I can put in 20 over 1, or 20, okay, in for my m. And my b value is my initial value. So the initial value that I'm given is going to be when x equals 0, when time equals 0, which is 40 liters. So there's my initial volume up top, 40. So I can write this 40 for b. So what I have is y, which is volume, equals 20 over 1, there's my slope, times x, okay, however many minutes, plus 40. So now I could graph that. I could also plug in any value for time for x, and I would get a value for my volume in liters. If I wanted to graph that, I could go ahead and do that. I'm going to leave it like that for now because what we really want to do is write an equation for it. You could go ahead and graph that if you wanted to. Let's do another example, okay? Here we have a question that says, you're going skiing at Big White next week. There are 2 ski rental stores at Big White. The first store charges a one-time $30 fee and then $8 per hour. Okay, right away, when we have these word problems, this statement right here refers to the first rental store. So that information, I want to keep that with store 1. Okay, so we're gonna sort of separate out our information because there's lots of information in this question. So rental store number 1, okay, here's what we know about it. We have an initial fee of $30. Okay, and then after that, they charge $8 per hour. Notice that is a rate. This is a rate, $8 per over 1 hour. So we have a rate of $8 per every 1 hour. $8 per hour is a rate which tells me that's also going to be my slope. Okay, that's a constant rate. Rental store 2 charges $14 per hour. Again, there's another rate, $14 per every 1 hour, and no fee. So the initial fee is nothing, $0. Okay, so let's separate this information out. So rental store 2, we have an initial fee of $0, and the rate is $14 per every 1 hour. So what are the two variables? What are the two quantities that are changing? Well, one thing is the time. How many hours you ski is a quantity. So let's define we need to have two variables, okay, for each quantity that's changing. So quantity 1 is time in hours, okay? And let's let, again, time is always on your x-axis, so let's let x represent time. You could also choose the letter t. That would be fine too. Okay, and let's let, the other quantity that we have then is money, cost, in dollars. Okay, and let's let y represent cost. Okay, so now what we can, if we go back to a rate for a minute, we see that on the top we have cost, on the bottom we have time. So my slope is really the change in cost, y, over the change in x. Okay, and the same is true for store rental 2. This is my rise, or my change in y, over my run, my change in x, my change in time. Okay, so I know that's my slope. So m, if I go ahead and write an equation now for each one, it's going to look like this. Okay, so let's write two equations. They're both linear equations because I have a constant rate of change. So remember, your linear equation looks like this. Y equals mx plus b, where m is your rate and b is your initial amount of y. Okay, because it's the value when x equals 0. So in this case, when time is 0, what would be the cost? Okay, so we start off with y. So cost is equal to the rate, which will be $8, or 8 over 1, times x, or times time in hours, plus the initial fee, which is 30. Okay, there's a linear equation for the first one. For the second rental store, we can do the same thing. Y is equal to x plus b. Well, y is equal to the rate, which is going to be 14 over 1, times time, or times x, plus our initial fee, which is nothing. And so we could simplify that to y is equal to 14x, or 14 over 1 x. Okay. Excellent. So there's our we've created a system. Two linear equations. We could then graph them. Okay, or we could solve them. I'm just going to pause the video for a moment, and then I'm going to carry on and solve this system in the next short video.